Hello all. In today's session, let us understand about water turbines. Water turbines are classified into two types, impulsive turbines and reaction turbines. Under impulsive turbines, we have Pelton turbines and turbo turbines. Under reaction turbines, Francis and Kaplan turbines. Now let us understand what is impulse turbine. An impulse turbine is a specifically horizontal or vertical wheel that generally uses the kinetic energy of the water, which will strikes the bucket or blades to cause the rotation of the particular blades. So in an impulse turbine, water is generally forced to hit the turbine at high speeds. That means that there is a fast moving water in a is fired through a nozzle at the turbine blades to make them spin, that is rotate around. The blades of an impulse turbine generally are usually bucket shaped. The input or they take the fluid and direct it off at a particular angle. So generally the wheel which is rotating is covered by a housing, and the buckets are the blade shaped, so that they turn the flow of water about nearly 170 degrees inside the housing. So generally an impulse turbine is one in which the driving energy is supplied by the water in kinetic energy form. Similarly, when we talk about reaction turbine, so a reaction turbine is nothing but it's a type of turbine that develops the torque by reacting to the pressure or weight of the fluid here. Here the reaction turbines are commonly used in situations where the water level is low level, but it has high flow rates. And these turbines operate under hydraulic energy, pressure energy, and a part of the kinetic energy too. So examples of these is Francis and Kaplan turbines. Now let us see the diagram of a Pelton turbine. So you can see here in the Pelton turbine you have bucket shaped blades, and the flow is indicated here, flow from the penstock, and the jets and the tail race. So you can see there in a Pelton turbine is also basically a impulsive turbine. So here this turbine is suitable for, as we discussed, high head and low flow plants. So what is high head means? If you have more than 200 meters distance, we mention that as high head. So here, according to the turbines, generally there are two types of Pelton turbines are used in hydroelectric power plant. What is the two types is single jet turbines and multiple jet turbines. So generally most of the Pelton turbines are horizontal shaft type, as you can see in the diagram here. So here horizontal shaft type water turbines, they have the two nozzles, but more than two nozzles also became provided. Similarly, in a vertical shaft type water turbine can also be used. So here, as you can observe, the water which is flowing from the penstock is allowed to flow onto the bucket shaped blades. So here the potential energy of the water in the penstock is generally converted into the kinetic energy, and it passes through the nozzle. So here inside pressure of the water is same as that of atmospheric pressure. So it generally consists of the rotor, which is placed in between an elliptical shaped buckets, here you can see here, along with the periphery of the turbine. Now generally these buckets are bolted fixed on the runner, and integral casting of pivots with the runner is also possible. So this is how generally your Pelton turbines works. Next is we can observe the diagram of Francis turbine here. So in the Francis turbine, you have the runner, draft tubes, guide vanes, head covers, water inlet, main shaft, operating ring, and water guiding vanes and spiral case. So in today's world, most water turbine used today is Francis turbine. So generally these Francis turbine are very good in nature. They operate in the head range of 10 meter to several hundred meters. Both for the lower as well as medium height, it is suitable. That's why Francis turbines is most preferred nowadays. And the output ranges from few kilowatts to 1 gigawatts also. So Francis turbine is also a type of reaction turbine, which means that the working fluid changes the pressure as we discussed in the reaction turbine, and it moves through the turbine giving up its energy. So here water has radial entry and axial exist. And these Francis turbines works based on the velocity of the water and difference in pressures, and these difference in pressure do generally act on the front and back of the runner bracket. Here we can also they adopt lift force and impulse forces responsible for the movement of the runner. This is how your Francis turbine is generally worked. So there are different types of turbines. So when we compare difference between impulse and reaction turbines, so we can say that all hydraulic energy is converted into kinetic energy through the help of nozzle in an impulsive turbine, and here in the reaction turbine only some amount of the available energy is converted into kinetic energy before the fluid enters the runner. So here in the impulsive it is based on the water jet change, pressure remains the same throughout, but in case of reaction turbine the pressure and velocity changes as the fluid passes through the runner. Pressure at the outlet is much higher than the compared to outlet. Inlet pressure will be greater. So this is how your different types of turbines works in a hydroelectric power plant. Hope you understood. Thank you.